Now, we have some missing number problems for adding multiples of 100, 1,000, 10,000 or 100,000. So first, 56,500 plus what equals 61,500? Well, if we highlight the digits that have changed, this 56 has changed into 61, and 56 plus 5 is 61, so our missing number must be 5,000, because 56 plus 5 is 61, but then our hundreds, tens and ones digits have stayed the same, so we need 3 zeros after the 5 to show that 5,000 has been added. Now 93,300 plus something equals 103,300. If we highlight the digits that have changed, the 9 has turned into a 10. Notice we've gone from a 5-digit number to a 6-digit number. So, because 9 plus 1 is 10, our missing number is 10,000. That's a 1 with 4 zeros on the end, because the last 4 digits of our number have stayed the same. 290,005 plus what is 590,005? Well, here it's just the 100,000s digit that has changed. 2 plus 3 is 5, so our missing number is 300,000. That's a 3 with 5 zeros on the end, because the last 5 digits in our number have stayed the same in our answer. And now 299,850 plus what equals 300,350? Well, here it's the first 4 digits of the number that have changed. Now we have 2,998 circled here, and then 3,003 circled in our answer. Now if we add 5 to 2,998, we get 3,003. So our missing number is 500, because the last 2 digits of our number have stayed the same in our answer, and 2,998 plus 5 is 3,003. So we can use place value counters to represent the addition. Our first question, we started with 56,500, which we've shown here using place value counters. Now we needed to make 61,500, and we could do that by adding 5,000s, because remember, when we have 10,000s, we can exchange those for another 10,000. So we can add 1, 2, 3, 4,000s, then exchange, and then add our 5th thousand. So we've added 5,000 counters, and that's given us 61,500. Then we started with 93,300, which we've shown here. We needed to make 103,300, but we could do that just by adding one 10,000 place value counter, because now we have 10 10,000s, and we can exchange those for 100,000. So that gives us 103,300. Then we had 290,005. We spotted that only the 100,000s digit had changed, so we just needed to add 3 100,000 counters, and that gave us our answer. Then we had 299,850, which we've shown here using place value counters. Now we only needed to add 500 counters, because the tens and ones digits had stayed the same. But remember, when we add hundreds, digits to the left can still change, because we need to regroup. So in our number, we start with 8 hundreds. We can add just 2 hundreds, and that gives us 10 hundreds. But we can exchange 10 hundreds for 1,000. Now we have 10,000s, so we can exchange those for 1 10,000. And now we have 10 10,000s, so we can exchange those for another 100,000. So that was just adding 2 more hundreds, and we need to add 5, so let's add 3, 4, 5, and then you can see that we have 3 100,000s no 10,000s or thousands, 300s, and we still have our 5 tens. So here, because we needed lots of exchanging, just adding 500 counters changed our number to 300,350.